My name is Henry Glogau. I'm passionate about designing a self-sustaining future. At the end of 2019, I travelled to Chile as part of my master's program in architecture and extreme environments. Through a local NGO called Techo, I was able to establish relationships with an informal settlement community called New Hope. During my month-long stay, I learnt about the significant challenges these communities face on a daily basis. In particular, access to electricity, sanitation, and water. Many of these communities are disconnected from formal systems, which leaves them with unreliable, unsafe, and expensive solutions. This led me to wonder about what resource opportunities already existed in these environments. How could we utilise their abundant solar energy and seawater? My initial design took a holistic approach to providing coastal informal settlements with water, natural light, and energy through a solar desalination skylight. We see the same process in nature through evaporation, condensation, and precipitation. This powerful process can kill dangerous pathogens, remove salt brine, and heavy metals. Reflecting on the initial design, and through the Lexus Design Award mentorship program, I realised there was a larger potential impact to be found in a more accessible, adaptable, and scalable solution, which could be implemented in a variety of different contexts with readily available materials. I continue to explore the underlying principles of solar distillation and living with resource production, but embodied in a new way. How could my design offer more than just water production, but also provide a shaded public space for the community? I continued to look into the process of seawater desalination, polluted water distillation, with an additional rainwater capture feature. Conventional solar still designs have limited accessibility in this context. I wanted a simple and affordable design which had qualities like deployability and large surface area, whether that was a ready-to-go product, hybrid fabrication, or fully locally sourced and fabricated. I've considered the systems and networks which are already in place to help support the distribution of my design. My new proposal is a portable solar distiller that is a low-tech solution which merges resource production within a deployable architecture. The essential components are the bamboo support structure, internal mechanism for capturing and distributing distilled water, and a UV-resistant plastic for water storage. The bamboo structure can be manufactured and assembled locally, guided by a simple instruction manual. The joint system can be created through techniques such as rad and woven joints or natural rubber bands. The solar distiller can be flat-packed and deployed in seconds. It is made of a transparent plastic top and heat-absorbent plastic bottom. This can be easily attached to the bamboo structure for quick deployment or storage. A 2.4 metre diameter is expected to produce around 18 litres of purified water a day. The internal mechanism holds the two plastic layers and acts as a water funnel and tap. The same design feature can be achieved using readily available materials, such as plastic bottles and plastic sheets. The structure can be adjusted to create different sizes for different water needs. The first step is to fill the internal basin with either contaminated drinking water or seawater. Throughout the day, the solar energy from the sun will naturally heat up the water. The design captures the evaporation and condensation before going into the atmosphere, directing the distilled water to the internal water storage system. The top has a seal which allows for the rainwater to filter through. The water access valve has different attachable options. This design can be deployed in many ways, whether that's utilising the ground as a natural insulator or hung between buildings. With the direction our climate is going in, the topic of resource access and water scarcity will be a prevalent challenge in many people's lives, no matter where you live. We must continue to consider autonomous and low-tech methods of resource production, so we can all have access to essential resources.